I designed this machine to juggle ping pong balls completely without human interaction. And although it seems very impractical, for me I couldn't pass up the thought of how cool it would be to actually see this thing juggle. With the entire process of designing, building, programming, and testing, this video tells that story. About a month ago, I sat down and began drawing out different design possibilities through a few rough sketches just to get my ideas down on paper. Throughout this time, my goal was to come up with a design that was cheap, had the least amount of moving parts, and in which I could actually build with accessible materials. Also during this time, I asked questions like, what objects would I juggle, what materials would I use, and the biggest one for this project was what would I use for the propulsion force to actually launch the objects. But after about a week of brainstorming and planning, I figured out the most efficient design. And so with the chosen design concept, the next step is always CAD, and as you can see in the model, there are several key components to the design. The first is the ability for the horizontal and rotational directions to be adjusted. This was key to my design because I didn't have a way to test how far or at what angle the balls will travel. So with that, I needed to have a flexible design in which I could manipulate after putting it together. Along with this, the other key component to the design is the entrance ramp in which leads into one of the cups. And this is my method of incorporating the third ball into the juggling cycle while the other two are already being launched. With the initial CAD design finished, the next step was to gather the physical materials and then print the 3D printed custom parts. And after a trip to Ace and waiting for the printer to print, it was now time to start the fabrication process. To focus less on the assembly process, here's a quick time lapse from start to end of me building the juggling machine. Alright, so as you can see, here's the first finished design of the project. Looking just like the CAD model, at this point in the project, all the electronics components are in the machine. For the project, I used 2 solenoids as the launchers, 2 relay switches, some jumper wires, an Arduino with a breadboard, and also a 9-volt battery. I decided to store all these components in the small red box to make the project look more professional. But immediately after finishing the build, I realized I was about to run into some major problems, and I'm just going to be honest, there were several huge flaws in my initial design. First, without placing the soft material inside the 3D printed cups, it was almost impossible for the ping pong ball to not bounce out of the cup. Ultimately, this was due to the high elasticity of the ping pong balls, and it wasn't even that I didn't think this would be a problem, but it was that I thought this problem would be a lot easier to fix. Second, I didn't plan to counterbalance the weight of the overhanging juggling arms, which caused the arms to not be at 90 degrees. As a result, the balls wouldn't be launched toward the receiving cup when the ball starts to juggle in its motion. To correct this issue, I simply attached horizontal rods opposite of the arms and used bolts to counterbalance the weight. In return, the center of mass could be directly on top of the vertical beams and would make the arms at a 90-degree angle. Third, due to the tips of the solenoids being round and also a number of other factors, the launching of the balls was so inconsistent that the machine would hardly have a chance to work without the ball hitting part of the cup and bouncing out. To correct this issue, I simply continued to add the red cardboard pieces until the ball had only a tiny chance of bouncing out. The reasoning for this was to simply provide more forgiveness to the balls bouncing by adding more areas to the cups. And the fourth major flaw is the biggest, and it has to do with the balls constantly crashing into each other after they had been launched. And prior to designing the machine, I had thought of how when we as humans juggle, our hands rotate back and forth in order to avoid throwing the balls into each other. However, when I designed the machine, I thought I could program the timing in such a way where I could avoid this from happening. But after continual attempts of the ball crashing into each other, I knew some larger changes had to be made to the machine. Truthfully, this problem brought up one of the biggest learning opportunities throughout this project, because I didn't realize that if my launchers are at the same height and same angle, the trajectories of the ball will follow the same path as they go through the air. As a result, when the ball is launched from each side, the ball follows a perfect parabolic shape in which matches the ball being launched from the other side. To solve this problem, I ended up shortening the arms by over a ball's diameter in order to allow the balls to follow the same trajectory, yet avoid colliding. This is why, if we look at the final design from a bird's eye view, the 2 arms are at different lengths. Also with the final design, the cups only have the red extensions on one side, and that's due to the fact that the balls have to land on that side or else they'll crash into each other. After finding solutions to the major design flaws, The machine worked fairly well, however, there was still one major problem that had to be fixed, and it is that around every third ball that landed in the right cup, the ball would sneak through the entrance gap where there is no wall to stop it. But this also created a problem because if I blocked that wall, I would have no way for the third ball to enter into the juggling cycle. To solve this, I simply created a little arm with a section of wall that moved with the servo motor. By doing this, it allowed me to get both the third ball into the juggling cycle and to cover up the gap in one motion. As a result, it gave the machine a sort of robotic touch, and is probably one of the coolest aspects of the machine. As you can see, after all these corrections and the problems and solutions that this project has gone through, the current status is vastly different from its original design. And so I think it's about that time that we go ahead and actually see this machine juggle. After solving all the repetitive problems, I would overall count this project a success. But one of the main reasons I built this machine was to put it to the test and have a little competition against its creator. So I'm going to go against the machine in a little juggling competition, and hopefully the machine can beat me out. 3, 2, 1, go. One super awesome thing about building these types of projects is that they're not only unreal to see working for the first time, but with each new project that I've built, they also have helped me learn so many new engineering concepts and also really expand my knowledge in circuitry components. For example, by doing this project, I learned the basics of using solenoids, I discovered that relays can practically be used for anything, and also how to effectively use my DC power supply. Along with this, during the project, I used engineering concepts of sliders and also adaptability in order to progress at completing projects faster. If you guys are still watching this video, I just want to say thank you guys so much for watching all the way to the end. And if you're looking to help me out, be sure to like this video and also comment below just encouragement or something that'll help me out. If you're interested in subscribing to my channel, click this icon over here. And if you want to check out either physics or engineering videos, click either one of these videos up here. Lastly, I just want to say thank you guys so much for watching, and I'll see you next week.